I don't know if we talked about that specifically, but I know that we looked at all the existing infrastructure that's in there, and one of the challenges of trying to do this in a really built out environment is there's so much happening in there already that it was deemed to be the most kind of the safest, most efficient way to run the system is by doing new lines. But I've been told that there is potentially the technology to automatically switch off customers, but that would again have to be widely adopted by the utilities, and then there would still be the issue of having a contract with the customers.
Just to build off that, the distribution lines, how much is it in detailed in the report that's going to be held as far as the O&M and then the tariff?
It will be, so we have all that information. I think it'll be more summarized in the final report, but if anyone wants any of the really detailed nitty-gritty, we'd be happy to share it with you.
Thank you.
Sure.
All right, we're moving over to the North Bay, headed to Napa and Sonoma with Greg Thomson from the Clean Coalition.
Great. Hello, everyone. I'm Greg Thomson with Clean Coalition, and a lot of good discussion this morning on microgrids and the scale of those and the potential for them. And we're going to talk today about a project up in the North Bay for both Sonoma and Napa counties, the North Bay Community Resilience Initiative. And this is as a result of the unfortunate wildfires that happened up there. And what has happened is a very qualified team of people have gotten together and said, we're going to rebuild right. And part of it is, of course, getting people's homes rebuilt for those who lost their homes. That's the key aspect of this. The most important thing is people lost their homes, right? So you want to get their homes rebuilt easily, quickly, and affordably. But the other part of it is bringing together the grid side, the microgrid side, the community microgrid side, so that we can actually have resilience and sustainability to support those homes, and to also provide a model for how to do this, not just in areas that need to be rebuilt, but in all areas. So it is a replicable approach. So I'm going to just walk through, sorry, and how do I do the, where's the arrow? Arrow. There it is. Got it. No? There it is. That one. Okay. I'm good. Okay. So first of all, a little bit about the Clean Coalition. Clean Coalition is a nonprofit, and the mission is to accelerate the transition to renewable energy and a modern grid through technical, policy, and project development expertise. And so our approach is to do analysis and planning. We do full cost and value accounting for distributed energy resources. So we get deep into what is DER, what is its value, and how do you get it onto the grid, essentially. We do power flow modeling, DER optimization. We've worked with multiple utilities on that. Program and policy design. So how do you procure DER? How do you do this in a way that's scalable, financially viable? Things like feed-in tariff models, things like wholesale procurement from entities like utilities and CCAs, that kind of stuff. And then finally, these components kind of lead into community microgrid projects, which we've done design and implementation in multiple areas. And so our community microgrid approach is helping to shape how this North Bay Community Resilience Initiative is bringing the community microgrid elements into supporting these homes being rebuilt. So we all know this, energy it's critical infrastructure. We've talked about the centralized model earlier today and what that carries in terms of risks. It is costly, it's aging, it's inefficient, it is, Tesla and Edison coming back and saying, hey, really, it's Edison's model that makes sense here. It's a distributed model that will help us protect energy as a critical resource from extreme events, weather, as well as security. And if you have a big event or a security breach in a centralized model, and I come from a background of many years in internet startups, it doesn't work. It breaks down and millions of people are affected, and that's why we have a distributed model for data and software, and we need a distributed model for energy now as well. And community microgrids bring that distributed model to the forefront, and it makes our energy cleaner, more reliable, and resilient. And we talk about, federal initiatives to make the grid more resilient, and they talk about a centralized source of energy for that. We all know that's just nonsense. It's also more affordable. So traditional microgrids are really single customers or single locations, if you will. So a campus or a building or an office complex. What we're talking about are community microgrids, which have been discussed earlier as well, which serve thousands of customers. And typically we're talking about a substation area or multiple substations. So it's not, a block can be an eco block. That's the Oakland eco block is great. What we're talking about is broadening this concept of a microgrid to a whole community area. So this is a modern approach for designing and operating the electric grid. It's stacked with local renewables and staged for resilience. So resilience being a key aspect of this. It's a local grid area served by one or more substations. It has an optimal penetration of local clean energy and other distributed energy resources. So we look at a substation area and we design in, where do you put solar? Where do you put storage? What are the amounts? Where do they fit with the existing distribution grid lines, given the capacity of those lines? And that data is available now. And so we can look at the entire substation area and come up with the result of optimizing DER for that area based on loads, based on feeders, based on feeder capacities and everything else. And it does give you the opportunity to leverage the existing distribution grid rather than building in a big expense of trying to run new lines and all that stuff. And it's also built in is the ongoing renewables driven backup power. So looking at critical locations, knowing the critical loads of those critical locations, hospitals, fire, police, schools, shelters, and knowing where and how much solar and storage typically here in this state you would put in to serve those critical services during a big outage. But a community microgrid uses the transmission grid at normal times, and then if there's an outage, then you have these critical services being provided with local renewables, energy storage. And that whole system also is reducing peaks, helping with the evening ramp and flattening the duck curve. So there's a lot of benefits to this, as been discussed earlier. And then it can be readily extended, so it is a replicable model that can go in basically any substation area across the state, across the country. We talked about this a bit earlier in the presentations about microgrids and what are their benefits, why. And here, in this case, we really have four key benefits from a community scale microgrid that are not provided by today's centralized energy system. So we're lowering costs and increasing economic investment for communities, for the ratepayers. We're reducing the cost of electricity because we're eliminating the expensive peak periods. So we're not pulling energy off transmission during that peak time. It's going to be that evening ramp. The rates are changing, and that's going to be the most expensive energy. So if you have local energy, a local energy system like a community microgrid, you're reducing the amount coming off of transmission. So you're reducing the cost of that peak energy. You're reducing demand charges for customers who incur those extra charges based on peak energy. You're reducing the investment in more transmission infrastructure as well as more distribution infrastructure. So there's a ton of things that happens here by flattening the load shapes and having a distributed model that are cost savings. We're improving the overall performance because of that. We're replacing fossil fuels. We're improving the grid performance because we're distributing the performance so that we have better performance throughout the system rather than it being aggregated up into what the Cal ISO has to do to help with peaks. And that's just also serving energy to local transportation needs as we move to more EVs. We're providing resilience and security, as we talked about, so ongoing power to critical and priority loads that's generated locally and served locally. You can withstand multiple disaster scenarios with this, or security attacks. So it's transmission outages, distribution outages, whatever the scenario is. We've got distributed networks of energy that are going to be sustainable in those given disaster or cybersecurity scenarios. And then it's replicable and scalable, as I mentioned. So community microgrids feature local balancing, and we'll get into the North Bay project here in a second, but I want to give this background. Local balancing, we flatten and lower the load shapes across entire community areas. Again, we're reducing the system-wide peaks and saving everyone money. We're managing the variability and volatility locally, right? Instead of aggregating that across a bunch of places and sending it upstream, we're handling that stuff locally and then providing energy and resilience. And so the distribution grid and the transmission grid become partners in grid operations and grid efficiencies. And that's not the way we think about the grid today. We think about it pretty much centrally and then pockets of DER or microgrids, but we want to actually equalize how we use the distribution grid, the existing one today that we've already paid for, and how we use that to balance distribution and transmission better. One of the opportunities in local balancing is this sort of mostly untapped commercial and industrial areas in our communities. In medium-sized cities, there are tons of pockets of commercial and industrial roofs and parking lots that are an energy asset in our communities, and they're largely untapped today. And working in San Leandro, for example, we looked at all the energy use in the city, and we discovered that with about 10% of the roof and parking area used for solar, we could get 25% of the energy use of the city covered by that local clean energy, because the C&I areas use the most energy. They had the most greenhouse gas emissions in San Leandro, except for transportation, and they have the most opportunity for generating a lot of clean energy. So it was a really nice, synchronized, a nice fit, if you will, of having solar as well as storage used in commercial and industrial areas to achieve those goals, those greenhouse gas emission goals, those cost goals, those peak reduction goals. But you can also have surplus energy from those areas serving residential as well, with the way feeders work and as they're connected at the substation. So there's a way, again, to look at the distribution grid, analyze its capabilities, figure out pockets of opportunity for clean energy, community microgrid design, and have that serve the whole community, not just the local site or just around the local site. So in Puerto Rico, as we know, Hurricanes Maria and Irma decimated the island and the transmission and distribution lines, causing, widespread wind and flooding damage to the substations, to the generation and distribution facilities. It was the longest power outage in U.S. history, and this has become a unique opportunity to take a look at kind of a greenfield, if you will, space, and say, how do we do the grid right? How do we do a modern grid? How do we build back better? And they brought together a team of a whole bunch of experts, and you guys can read this list, and New York utilities, EPRI, Department of Energy, et cetera, NREL. So they came together and they said, well, what do we want? We want to implement resilience and hardening measures to increase the capability of the electric power grid to withstand future storms. So their recommendation is to use modern grid technologies and control systems, renewable energy resources, and new technologies such as energy storage and microgrids to make energy abundant, affordable, resilient, and sustainable. I think that's something we all want, we all deserve, right? Energy should be abundant, it should be affordable, it's got to be resilient, and has to be sustainable. And that's lowering the dependence on large central generating stations. And so this is a design coming from all these experts coming together to do this, to really showcase what a modern power system should be. And it's essentially really a community microgrid. And so we're looking at that and integrating our own community microgrid methodology and applying that now to the North Bay Community Resilience Initiative. And again, the objective is to make energy abundant, affordable, resilient, and sustainable. So we working with a team there, which I'll talk about in a minute, to rebuild the fire-destroyed areas with high levels of sustainability. That's homes and buildings and the electric grid. So it's bringing a modern, distributed, and carbon-free system that delivers substantial economic, environmental, and resilience benefits to the community. This will also establish a blueprint for rebuilding disaster-destroyed areas in a timely and cost-effective manner, and maximizes the economic and resilience value of energy as a critical resource to the ratepayers. It's a model for also operating a modern distribution grid. So we're working very closely with PG&E on this, who are committed to incorporating DER in the right places to help with resilience, to do cost-effective local balancing, have this interaction with the transmission grid, which we talked about with local balancing and local energy markets. So these benefits will once we get this design done and implemented, we'll showcase these benefits across both grid operations and balancing the grid, as well as economics. We're working on the building codes to ensure that they are advanced. I'm going to talk about the home packages that are being promoted, so that we have more resilient, safer, and cleaner building stock in communities. And then finally, the end result, one of the end results will be lowering ratepayer costs. So distributed energy resources will be utilized to defer or avoid these substantial costs in peaks, essentially, and infrastructure to serve those peaks. Here's an example, essentially, of the benefits, energy, economic, and environmental benefits of, let's say, 30 megawatts of solar. And we're not at the point where we know the results of the analysis for this project, so I don't have the number, exact number yet. But if you take 30 megawatts of solar, these are the benefits there. So 150 million spent locally versus remotely. I mean, these are really substantial new ways to look at how to value DER microgrids, but especially community scale microgrids. 50 million in avoided transmission costs, 20 million in avoided power interruptions. That's just energy benefits there. Economics, so $120 million in new regional impact for a community, 60 million in added local wages, 1,000 job years, 6 million site leasing income, and then the environmental benefits, of course, which you can see there. So in North Bay, obviously we had fires in Santa Rosa area and others in Sonoma County, as well as in Napa County. This is an example only of a location. So you can see the center there is the fire damaged area in the Lark Field and Old Redwood Highway corridor. It's really ideal for a community microgrid because it's got a single substation serving it. And we've done some preliminary analysis to show what the feeders look like and what the capacity is, and where the critical locations and priority locations would be. So we are looking at a list, for example, of critical and priority sites, the regional hospital, Burbank Center for the Arts, high schools, which schools can serve as shelters, of course, in an emergency, shopping centers, which again usually have a lot of roof and parking space to generate energy for a community area. Et cetera, one more schools there. And looking at just a preliminary design of a community scale microgrid here, you've got the substation on the left. Each of these rectangular areas are different segments of the distribution grid. These are not self-sustaining microgrids that are made from scratch and cost a lot. This is showing that using the existing distribution grid feeders and feeder system, you can have self-sustaining critical load areas, which are these rectangle areas here, and we break the loads into tier 1, which are critical, tier 2, and tier 3. Tier 2 being priority. Tier 3 essentially are loads that aren't served during an outage. Tier 1 obviously is served in some of tier 2 or all of tier 2, depending on how much energy you can get in a local system. So we go through and we'll work with PG&E on the areas that are chosen, and we'll go through the topology of the grid, the capacity of the feeders, and where the critical locations are, and the loads that need to be served, and we'll design into that the DER that makes up that community microgrid that makes that work. As I mentioned, PG&E is supporting, committed to this. They are working on the rebuild packages for the homes, which is in an upcoming slide, with Sonoma Clean Power in Sonoma County. They're committed to the aspects of this in terms of community microgrid features and grid modernization in sync with the rebuild for the homes there. They are going through their analysis. They've made some significant progress so far in the grid opportunities for the fire rebuild areas, and that analysis includes the analyzing the customer and feeder load profiles, estimating the duration of power required by building type, critical loads, priority loads, the circuit configuration, telemetry and control requirements, and the rough costs for deploying these grid modernization / microgrid features at various target locations. And that analysis criteria, they also look at where there's high risk areas due to wind and fire. So looking at vegetation, looking at poles and wires, and figuring out how to make that much more resilient than obviously it has been. Looking at the grid topology, so the capability to sectionalize the grid, as I was showing in that earlier diagram, to isolate areas during emergencies, and then the community layout, so the opportunity for local generation, for resilience, for critical services. So this analysis is currently underway. They're going to complete the analysis with us. We will work with the community to get their input on the best locations for having the community microgrid features support the rebuild of the homes based on the fires. And then one of the recommendations will be including microgrid-ready homes and designs. So this will be part of the community resilience zones, if you will. And this will help ensure that the homes and buildings are prepared for the grid modernization piece and the community microgrid piece of this in terms of design, electronics, wiring. So preparing for all of that. Just the key point here, you all know this, but homes and buildings are grid partners basically in this whole effort to get us to a lot less use of fossil fuels, Z&E homes and all that stuff. So it's really important to look at both how homes and buildings can be designed to lower energy use, become zero net energy, and also how the grid's going to operate to support that. And that's what we do with this community microgrid initiative. Obviously, the PV arrays on residences, PV arrays on commercial buildings. Again, we look at the distribution grid as something that exists. It's got capability to do this. We've proven it many times. And working with utilities, working with CCAs to engage the community in a community scale microgrid, leveraging that existing capability is really what gets us to the outcomes we want in resilience and sustainability and affordability, without having to put too much investment into this by not doing standalone microgrids. And on the homes, this is the Advanced Energy Rebuild for Homes program that Sonoma Clean Power is leading with support from PG&E and the Bay Area Air Quality Management District. So they've joined efforts to help homeowners look at a couple of designs in their rebuild. They're bringing financing for this. And this is going to be an enhancement to PG&E's longstanding California Advanced Homes program. So this is up on the Sonoma Clean Power website at that link, and we're all working to make sure that the people who were impacted by the fires have an easy way and a single source really to go to say, oh, what do I want to do with my home rebuild? And these are the two packages. I'll just quickly go through some key features, but you'll get these slides, and you can go to the link on the Sonoma Clean Power website. But the one on the left is an advanced energy home with some features, high performance walls, attics, 2019 code windows, high efficiency water heater, heating and cooling ducts that are well sealed, efficient plumbing, water efficient landscaping, Energy Star appliances. So you can see that's kind of a basic advanced energy home. The one on the right is the Z&E option. It's all electric Z&E, high performance walls, attics. It's smart thermostat, induction cooking, electric or heat pump clothes dryer, and both of these options, Sonoma Clean Power is offering a free EV charging station itself. And then both of these options you can choose also to add solar and storage on the roof, et cetera, to help with the whole economics and self support of Z&E or energy on the home. So these two packages are this is coming out basically in May. This is sort of in development, still being finalized, but it's coming out in May. And this will be offered to the homeowners who need to be rebuilt with financing, and then obviously on the grid side, PG&E and Clean Coalition, we are supporting all that with the Community Microgrid Initiative. This is the team, very important group of people up in Sonoma County and Napa County, supported by PG&E, Clean Coalition, Sonoma Clean Power, Rebuild North Bay, which is a group that's gotten together to help with the rebuild. Center for Climate Protection, which has been up there for many years doing climate protection initiatives, County of Sonoma, et cetera, et cetera. So there's a long list of key people who are working on this. And that's it.
A great presentation. I'm Arietta Chacos, advisor to the ABAG MTC Resilience Program. I have a question about one of the slides where you talked about improving building codes for more resilient and sustainable rebuild. So what are you doing on that?
Yeah, that's
Is anyone doing anything?
Yeah, there's a part of this is there's a group of people who are working on this, and you know, we're working on it. Sonoma Clean Power is working on it. PG&E is working on it. People like the new Rebuild North Bay organization are working on it, and everyone's trying to sort through what are today's codes, what are the codes that are already on the books for tomorrow, like 2019, 2020. What do we want, and what's the delta, and how do we get there? So it's in process, and there's a lot of discussion about it. Yeah.
Bruce Mass, thank you for that presentation. One of the key points I'm hearing when I compare the different presentations is kind of the key decision criteria around using the existing distribution infrastructure versus building another infrastructure on top of that. Could you comment on that and the trade-offs and feasibility?
Yeah, I will. I think there's two ways to approach doing microgrids at community scale or even at block scale or whatever. And one is trying to do something independent of the grid or only partially using the existing grid. And that's where you think, oh, I've got to run a line from this building to that building. And then it costs, you can't do it, or it costs too much money or whatever. The other approach is to understand that we have substations today that we've paid for and that work in a certain way, typically always sending energy downstream from the transmission grid. But those wires and those voltage regulators and those transformers literally can handle energy going two ways. Physically, the physics work. We've done power flow models on substations, and we've proven, for example, you can have a bunch of solar on C&I buildings. A lot of that's used during the day, because during the weekdays, because C&I typically are running processes during the weekdays. On the weekends, there's less energy being used by those C&I locations, and we proved that that surplus solar could travel back to other connected feeders at the substation and provide energy to homes on the weekends where people are typically using more energy because they're home, not at work. There's a natural balancing effect in our existing distribution grid, and all it takes is going through the analysis, understanding that that's an option, and working with the utilities and going through that analysis to leverage that existing distribution grid for all that it can do, because it's electricity running through metal. It's physics, and it can go both ways. Yeah. Does that help? I don't know if that answers. I mean, it's kind of a mindset and an analysis question that you take your area and you do that analysis, and then you come up with good answers.
So then, is that what we're getting already through things like net energy metering?
Yes.
Surplus power back into the grid.
We are, except for the fact that we're constrained by business models and utility and utility regulations, so that we can't. You can't take a warehouse that doesn't use a lot of energy and put solar on the whole thing, because you only do like 110% of the load in an existing home or building as net metering. That's not a physics problem. That's actually a business problem. We need to buy energy at wholesale in our communities in the biggest locations we can, regardless of how much energy is used on those locations, and share that energy amongst the substation or the community. That's what we should be doing. That's the best cost-effective way to do this.